This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This week is episode 643, and we welcome back Robert Bean. We're going to talk about what we call the Edifice Complex, IAQ, HVAC, building science, and COVID. Looking forward to a great show. Haven't had him on in 12 years, believe it or not. It's just amazing to us all. Anyway, before we get started, we have to thank our sponsors. They're the reason we can continue doing the show. And then after the show, don't forget to check out the afterthoughts.iaqradio.com site. Our marquee sponsor is Instascope at instascope.co. Our association sponsors are the American Industrial Hygiene Association, AIHA.org, the American Conference of Governmental Industrial Hygienists, ACGIH.org, the Cleaning Industry Research Institute, CIRI Science.org, the Indoor Air Quality Association, IAQA.org, the Restoration Industry Association, restorationindustry.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org. Healthy Buildings America 2021, HB 2021-America.org. Industry sponsors are AEML Laboratories, AEMLINC.com. Particles Plus, ParticlesPlus.com. Gray Wolf Sensing Solutions, GrayWolfSensing.com. TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to Andrew Gunzer, Certified Safety Consulting, St. Louis, Missouri, who was first to identify Andrew Cook as the AIHA member who published exposure limits in the Journal of Industrial Medicine, and upon whose work OSHA's permissible exposure limits are still based. The IQ Radio Trivia question for today, October 22nd, 2021, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IAQ investigations at tsi.com. Here's today's IAQ Radio two-part trivia question. Name both the inventor of a toy modeled after a construction method used to build the earthquake-proof Imperial Hotel in Japan and the toy he invented. Back to you, Joe.
All right. Robert Bean is a retired engineering technology professional, having practiced in the building, construction, engineering technology, and mechanical engineering for decades. He specialized in the design of indoor environments and high-performance building systems. He's a third-term ASHRAE Distinguished Lecturer, recipient of the Lou Flag Award and a Distinguished Service Award. He is also the founder of the HealthyHeating.com website and co-host of the Edifice Complex podcast. Welcome back, Robert.
Good to be back. I can't believe it's been so long, man. When was the time we was on? Was it 2009 or something like that?
I have it right here. 2009 it was, and it's hard to believe. It's been 11 years. You guys
you're at 643 episodes now. Is this 644?
643 today.
643 today. Congratulations.
Thank you. You were episode 115.
And are you going to announce it that this is your big anniversary this year?
Well, 15 years. We missed it, though. Cliff and I we just let it slide right on by here in the age of COVID. Everything kind of just went by the wayside.
Well, the three of us have a color in common, right? And so that happens. Shit goes by.
That's right.
Yeah.
Good to have you back. How are things going in retirement?
Awesome. We were talking before the show. Retirement is a myth. What it does, it allows you to jump into the things that you love to do, and so you end up becoming busier, or at least for me and I others that are in the same boat, we're actually busier than we've ever been. And it's a joy because we get to deal with the things that we want to deal with, right? As opposed to having to deal with stuff that we don't want to deal with. So it's good. Things are good.
I hear you. And you're not doing any consulting at all, just taking care of the healthyheating.com website and doing the podcast and, still volunteering a lot, I assume, for ASHRAE and others.
Yeah, do a ton of volunteer work with ASHRAE as much as I can. And, but yeah, I haven't picked up a slide rule and calculator in 3 years now, I think. So, and you know what? And I was actually thinking about this the other day. I actually kind of miss it. There is an element of joy applying mathematics, to the design and then managing that stuff on the job site, right? Seeing the numbers come to reality, and my co-host at the Edifice Complex, Adam Muggleton, he specializes in commissioning, and we talk about that a lot, And there was a guy, Dr. Robert Petitjean from the University of Charleroi. He was one of the first guys that taught me about balancing, for example. And he said, why the F are you doing any calculations if you're not prepared to go out into the field and verify it, right? And Adam's, philosophy is, trust but verify, right? So believe what the architects are telling you, believe what the engineers are telling you, but get your ass out onto the job site and make sure that things are supposed to be the way that they were designed, right?
What led to the name, the Edifice Complex? I loved it. First I thought it was the Edifice, and then I looked into it.
Well, it is a play on that. That's again, I credit Adam. I blame him for everything. We met, Adam and I met a long time ago, and I don't actually remember what year it was. We were actually in the course. I was teaching it. And so we just managed to stay in touch. And then somehow we ended up, I think it was San Antonio, Texas. Adam's going to have to correct me on this one. And I was there for an ASHRAE conference, and he was there, I think, for a commissioning conference or something like that. Anyways, I got a text from him and say, "Hey, Bean, where are you?" And I said, "I'm in San Antonio, Texas." He said, "I'm there too." And so he said, "Come on, let's go grab a beer." And so we, over several pops, had a good discussion. And he said, "I want to run something by you." And it's called the Edifice Complex. And I just started to laugh. So that's a great name. And Adam has this background in property development. I mean, he's worked on some big projects from JFK Airport to, the guy has been to, I think it's something like over 30 some countries, and he has clearance at many, many military bases around the world. Like, he's a pretty special guy. And anyways, he having that experience, the Edifice Complex was about the egos that float around in our industry and how the egotistical forms in architecture get in the way of good buildings. And so that was his idea, and I thought it was brilliant that we start to talk about ego in property development and how it's messing up not only the indoor environments for people, but energy and that type of stuff. And we don't have to be that way, right? I mean, there's great design out there, and we've seen great design. But a big part of the great design is human factor design, as you guys know, is one of my areas of passion. And when you let human factor design guide, you end up with good buildings that architecturally are beautiful, right? So that's how that all came about.
Are we making any progress in putting the Edifice Complex to the side and doing a better job of designing healthy and comfortable buildings?
We are, there's like a capacitor full of crap still in the system, but we are seeing on the fringes, these, I call them thoroughbred buildings, right? Where they've been designed with a philosophy of human factors. So the indoor environment, sound, lighting, odors, vibration, thermal, air quality. There's like the Manitoba Hydro building is a great example, as was the Colorado building, the research building down in Colorado, and there's many out there, right? But they were all based on the standards. How do we design a building that's in compliance with ASHRAE Standard 55 thermal environmental conditions for human occupancy, or 62.1 ventilation for, well, 62.1 and 62.2, right? So that covers both low rise and high rise buildings. And then lighting standards, right? So forget about the architecture. Let's just say first, okay, how do we satisfy people with the least amount of energy? And you have to design it with good architecture, and you have to design it with good enclosures, and you got to recognize how important interior design is. And then, and only then, do we look at the mechanical systems. That's the philosophy in these buildings, right? I mean,
Well-
so many thermal comfort complaints and lighting complaints and odor, whatever. Take a complaint that somebody has. It's primarily related to the architecture or the enclosure or the interior design. Hands down.
Absolutely. And I don't know, I wasn't aware until I went and looked at your website here recently. You've also got a book that you've written. Tell us a little bit about the book. I don't have the name in front of me. I know it was Thermal Comfort, and then here we go, table of contents. Anyway, I got the table of contents, but tell us a little bit about the book.
Yeah,
There we go.
God bless the BC Housing Corporation.
That's BC, you mean British Columbia, am I right?
Yeah, British Columbia Housing Corporation. And
Yeah.
they hounded me for a couple of years to put in a grant to sort of take what was in my brain as it related to that subject matter and put it down into paper. And you know, it's like you guys, you get busy and things just, you think about it. And okay. And so I think it was 2 years ago or something like that. Finally, they twisted my arm hard enough. I applied for a grant, got it, wrote the book. And because they funded it, a big part of it, we make it available for free. And it's really, it's kind of the Robert Bean alpha to omega view of thermal comfort. And it's written for residential buildings, but the reality is it's principle based. So it can be used in any building in any part of the world, really.
John, let's go back to the cover. I want to ask about the building you chose for the cover here, Robert. What building are we looking at here?
So this was when we were practicing, I think I'm trying to remember the numbers, but it was something like 80% or 85% of all of our clients were other professional engineers. And this was a client who was an engineer and wanted to build an infill. It's a beautiful piece of property. I mean, he has this awesome view of downtown Calgary. And a lot of thought went into the building, and we helped with that process. And it's a great, for the most part, it's a great structure. And other than there were some things that came about in that project that were a challenge for us thermally. And a lot of it had to do with the window to wall ratios and how that affected what we call the mean radiant temperature, which I've talked about ad nauseum, right? But so yeah, the window to wall ratios were an issue. And then also the reluctance, even by professionals, to do depressurization and thermographic imaging tests before they enclose the structure. And this was another example where, we said, like, listen, for the minor amounts of money, get this building depressurized and get someone walking around with a camera and see where all the flaws are. Well, of course, one of the problems as engineers have and technologists have is that we think we know what's going on all the time. And so that advice that we gave him was refused. And then subsequently led to some issues. I mean, the first winter they started having leaking problems. There was moisture that was condensing on steel beams that weren't insulated, and as a result of the leaking that occurred, then the thermographic guy came in, depressurized the house, and then they found lots of areas that were not done the way they should have been done. So even the experts and those that think that they know what's going on, for a few $100 or whatever it is, in the US and different parts. I mean, sometimes it's a little bit more money than that. This was a little bit more than that. Get it done. It takes nothing to put a house under a negative pressure and have somebody walk around with a camera, right? Saves you, in this case, tens of thousands of dollars, right? For, you could have solved it at the beginning. So that's why I picked the project, because the philosophy of the building was really good. The ethos of the owners was really good. It was all about the indoor environment, because they did a marvelous job of picking interior finishes for low VOC content, that type of stuff. They had a beautiful view of the city, so there was no way we were going to win that argument in terms of window to wall ratio. So we had to compensate for the glass. So it was a challenge, but it was also a joy to work with them, because they were scientists, both of them, and they understood what the challenges that we were facing, And we understood their challenges as scientists, but also the fact that this was their home and they wanted to enjoy the outdoor world when it gets to -40 in Calgary. So it was a good project. And we've had lots like that.
I think we have to keep in mind you are in Calgary. It does get a little cold.
Just a little bit.
North of Minnesota, or well north 40. Of Montana. -40 is not unusual.
Not unusual to get to -40. Yeah.
I noticed in your book you have a topic called a chapter, thermal comfort illiteracy, demonstrating the state of the knowledge. I wonder if you could kind of summarize what that's all about.
Oh my God, yeah. So I started doing research work in my courses. This is going back a long time now, and I would ask people in the audience what they knew about thermal comfort and the standards and the design. So I developed a series of questions, right? And I was at it was a building science summer camp, and I remember there was probably, well, you guys have been there. Well, you guys you're like part of the DNA of that camp, right? Yeah, your names are etched on the cornerstone of that activity. So I asked everybody in the room to stand up. There was like 450 people. These are all of North America's top engineers, builders, architects, contractors, right? Like there's a lot of brain power in that room. It's actually kind of intimidating talking in front of that crowd, right? Yep. And then so I asked them, I said, okay, well, how many people here, if you're involved in thermal comfort, either as an insulation manufacturer, depressurization, window manufacturer, engineer, architect, whatever, you can remain standing, right? Well, most of the audience keeps standing because everybody has some tie into thermal comfort one way or another, right? Yep. And then I think I'm at the end of and then I asked them, okay, so how many people here that are part of thermal comfort, how many people can actually name a standard? Well, at that point, 50% of the room sits down, right? And that right there it should be a shock for us. And then I asked the question, for those who remain standing, can you actually name the 10, now 11, or now 11 metrics within the standard? And then half sits down. So now you're sitting there with a quarter of the people in the audience. And then I said, okay, how many of you can actually, describe or do it? And so anyways, we get through the sequence. And at the end of the day, less than 0.5% of the people can actually do a compliance test with ASHRAE 55.
Wow.
450 of North America's top brains, and only 1.5% of people can actually do a compliance test. And that number is not indicative or to that particular function, the building science summer camp. We did that at the camp, summer camp, or spring camp up north that John Straub was part of, and Gord Cook and Andy Oding and their crew at Building Knowledge Canada. But we've done that exercise for, I think it was going on like something like 15 or 20 years, and the same results.
Amazing. These are the top people.
Yeah. And so it's amazing, right? So because when people get complaints, and there are so many complaints on thermal comfort, and people always point to the building code, well, look at the thermostat. It says 70 degrees on the wall. If you're in the US, 65 or 68, whatever it is. And air temperature, using air temperature as a proxy for thermal comfort is like saying baking soda is a cake. There's just so many other ingredients. It's a lame proxy, so yeah, anyways, that's.
But are we making some progress? Obviously ASHRAE's made progress over the years in that respect. Are we making any progress with the engineering community and the architectural community?
Yeah, we are for sure. And part of that comes from the post-occupancy surveys that have been done in commercial buildings. And the Center for the Built Environment, has done a great job of drawing attention to that, where we're looking for like 85, 90% compliance. And when we say compliance, so if you take 100 people in a space, just say 80, 85 of them, 90 of them are happy, right? That there's no complaint per se that can't be resolved. But we're hitting like less than 50%, so we're not even anywhere near the requirements of the standard. And so that's when earlier on, we talked about when you look at good buildings and buildings that are designed around the human factors, those buildings have high compliance rates. So we know how to do it. We know there's nothing that we don't know, that's where we're at in the state of technology. And it all comes down to like the 4 horsemen, right? The first horseman is architecture, making buildings simple enough that they're not complicated to build, right? And reasonable window to wall ratios of glass glazing systems that are appropriate for the climate. That's the first thing, right? And get rid of the menagerie of roof lines that we see in buildings, right? The complex geometries. And then the second one is the enclosure itself. Reducing the thermal bridging is a huge thing, right? Making sure that the industry needs to forget about air temperature. That's the first thing, because the body, 60, and the ASHRAE handbooks are clear in this, and the medical textbooks are clear in this, and the indoor environmental guidebooks are clear in this. 60% of the sensible heat transfer from the occupant to the space is done via radiation. It's not air temperature. So for F's sakes, just set air temperature aside and you'll start to think about the space from a human point of view, and that's the radiant relationship. So if you want to know why people are cold in 100% window to wall ratio, it's because the body's trying to heat up the glass at minus 30 or 40 degrees Fahrenheit. It's insane, right? So stop it. Just stop it. Like this air temperature and thermostat, just stop it. I don't know what else to say. Like, it's a stupid way of measuring thermal comfort as a metric. So improving or reducing thermal bridging, reduce the amount of glass, put in better glass and exterior insulation. And well, you know what? Just follow the shit that Joe and John and all those guys are, and Christoph Irwin and all those guys are talking about. They know what they're doing. They got it right. And so then the third one is interior design. People never give the interior designers. I'm not talking about decoration here. I'm talking about interior designers. They're professionals, just like architects and engineers are. Right, 4-year university degree, 4 years of articling. They've got a code of ethics, protect human health and safety and people. Like these people have game, right?
Yeah.
They're in charge of fire exits. They're in charge of coordinating with structural and electrical and mechanical. Like these people aren't stupid, right? And but when I say interior design, I'm actually, we actually need to start with the exterior to get the interior right. So the first thing is window treatments, right? So if you're going to have glass in a cold climate, you want to have lots of glass, well, then put in insulated window treatments, right? If you want to have lots of glass, well, then get the window treatments on the outside in the warmer climate, sunny, right? So the interior designer starts actually at the exterior and then works its way in. But also, think about in terms of air quality. That's a big issue these days, right? Well, if you want something to break down, a synthetic material to break down and create gases, VOCs, and there's lots of hydrocarbons and synthetic materials, well, then just expose it to shortwave radiation, right? And get it wet, right? And all of a sudden you got particles floating around, you got gases floating around. And so if we want to stop that, well, then work with the interior designers to work with more natural materials, things that aren't synthetic, and fix the glass again.
Fix the glass. It comes back to that glass.
The glass affects thermal comfort, it affects lighting, it affects air quality, it affects sounds. It affects absolutely everything, even vibration,
Oh, that's I didn't think of that. That's a good point.
Yeah, we've all seen glass shake when, some big truck rolls by, or, there's whatever, trains, planes, and
airplanes, all that stuff.
All that shit. Yeah.
Okay. That's good. I like it. I do, a little bit of indoor air quality. I've watched it over the years a little bit, and I'm still confused over which is the best green building program out there. You've got the USGBC LEED program. We've got are those helping or hurting us?
They're definitely bringing awareness to the subject matter. There's no doubt about it. They have brought awareness to these important elements. The WELL folks, have sort of taken it to another level in terms of their work with, the universities and doing research work. They have a full-time lab. I think they can accommodate something like 8 or 9 office workers, right? And so they've done a lot of work on how people's stress levels are affected by the indoor environmental quality. So I'm a fan of WELL from that perspective. I really like Active House, which hasn't really sort of found a strong foothold here yet in North America, but it has in Europe, Denmark and Germany and Norway, Sweden, these types of areas. And what I like about Active House is that they do have a specific requirement for indoor environmental quality. A lot of these other programs even lead to some degree, but they, in terms of, I suppose if as time went on, they would become more attuned to the specifics of these standards. like Well has, for example. And I know Well and Lead, of course, and I don't quite understand the relationship there, but that it does
I don't
exist.
either.
Living Building
about-
Challenge is another one that's really good that I really like. They've all brought
Okay.
awareness to it, but the brass tacks are, and this is people need to understand this. And have you ever had Chris Mathis on from FASHRAE?
No.
Okay, he's what a gentleman. I mean, most FASHRAE folks are gentlemen for the most part. Get Chris on, and he'll talk about architecture and buildings. But anyways, something like, Chris, forgive me if I get these numbers wrong, but it's something like 80% of all buildings in North America are under 20,000 square foot or square feet. And why that's important has to do with the role of professionals on the job site. So a lot of buildings, in fact, most buildings in North America, there's no need for professional engineers and designers, right? And especially on the HVAC side. So you have people that are designing systems that are just for compliance with building codes. Well, the building codes are there to protect people so they don't die from being inside the building. There's nothing about, discomfort. Like building codes have nothing to do with discomfort. There's no statement in the building codes that says, if you do this, that you're going to be comfortable. It doesn't exist, right? So what we're saying is that, in order to solve the bigger issues in our continent is that we have to find a way that when people design buildings where there's no professional involvement, that they recognize the role of the people. It's ultimately why the buildings exist. It's, we're not housing parrots and chimpanzees and
in most cases,
right? These are people. And so we have an entire world all focused on energy. But every BTU and every kilowatt and every cubic meter of carbon emissions is a result of people avoiding discomfort in one form or another. So you can focus on, efficiencies of heat pumps and chillers and boilers and furnaces, and you can get into all of that shit all you want all day long. But until you start to address what people are doing, which is trying to avoid discomfort, you're going to use energy. So let's call it what it is, right? Is that we have people that are pissed and they're using energy to become unpissed.
That's a good way of looking at it.
That's what it is. Like, let's just call it what it is, right? Let's stop pussyfooting around it, right? I mean, I'm 60, I'm retired. I have to sometimes watch what I say, but the reality is that we have an entire industry, architectural property development industry, that is ignoring the very people that are in the buildings that we're building for, right?
Yep, absolutely.
We gotta stop that. It's nonsense.
Let me throw another one out. Passive house. You mentioned, actually, I'm not familiar with active house, so I'll have to look into that a little more. But what about passive house?
Yeah, passive house, again, have done a really good job of bringing awareness to building performance. And, one of the consequences that you get from designing and building to the passive is you do solve some of the issues, not all of the issues. We've done forensic work on passive houses that, on paper looked like that they were going to provide comfort for people, but window to wall ratios again.
Yeah. Okay.
And that was a big thing. So lack of shading, large window to wall ratios, inadequate fenestration performance for the climate zones. So, but that's not to point out passive house has flaws, because they all have flaws, and the flaw is that everybody does these designs. They try to use mathematics to describe building performance in a compliance with a standard or a code. But again, everybody forgets the people, right?
That's absolutely. I think maybe we'll go to halftime now. Thank our sponsors. But John, when we come back, can you pull up that picture we had earlier from Robert's book of the newscasters? I think that's an important point to bring up.
Yeah.
So we're going to stop for a minute and a half here. We're going to thank our sponsors, and we'll be back with the second half of our interview with Robert Bain. Our marquee sponsor, Instascope. More jobs done faster with the future of IAQ assessment technology. Unlimited samples, instant results, and cloud-based data at Instascope Our association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org, ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science, ACGIH.org, the Cleaning Industry Research Institute. See more deeply through science and research, CIRI science.org. The Indoor Air Quality Association, IAQA.org. The Restoration Industry Association, the granddaddy of the restoration industry, restorationindustry.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Healthy Buildings America, Honolulu, Hawaii, January 18 through 20, 2022. HB 2021-America.org. Industry sponsors are AEML Laboratories. Free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. Gray Wolf Sensing Solutions, over 20 years manufacturing accurate, reliable IAQ instrumentation for portable, short-term, and continuous monitoring. GrayWolfSensing.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations. TSI.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, I love the comments coming in. No questions yet, Robert, but a lot of good comments there.
That's good.
Anyway, John, pull up that picture if you would, because I think this just illustrates in one photo why what you said about temperature is so important. Tell us a little bit about why you put this in here, Robert. It's in your book, by the way.
Yeah, you know what happened is a couple of years ago, a few universities were releasing research work on thermal comfort, and they turned it into a gender war. And unfortunately, the big newspapers picked it up, and by the time FASHRAE responded, it had already gone around the world. And it's not a gender war. It's never been a gender war. It's been about giving the people the opportunity to adapt. And so I was reading these papers, and it's just coincidental that this came up on my screen. And I'm looking at it and I'm going, there's the reason why, people complain about discomfort in office buildings. It has to do with clothing. Right. And it's not a difficult concept to figure out. I mean, if you wear less clothes than someone else, you're going to experience the space differently. And so going back to my comment about 60% of the sensible heat transfer is radiant. Well, if your skin is exposed to cold surfaces, no wonder you're complaining, right? Compared to the other guy beside the lady there, look at, he's wearing a full suit, right? So
with the tie pulled up tight around his neck.
Exactly. Right? Every time I read, bullshit about indoor environments, and COVID's in there as well, by the way, that whole discussion. And I keep just thinking to myself, like, look around you. I don't know what happened to critical thinking in our society, but it's vaporized, right? And I see people talk about thermal discomfort and they blame it on gender. And I look at these people and look at their wear and I go, are you blind? The reason for it is right in front of you. It's right there, right? And it was the same thing when, we were in Florida at the ASHRAE conference in 2020. And when we got news that the virus COVID was starting to find its way around the planet. And as soon as I heard that, I started ordering up N95 masks. And because I don't know if you guys know this, but I almost died from respiratory failure. And so I'm a little sensitive to respiratory illnesses, right? So I ended up buying inventory N95s and building, the Corsi Rosenthal boxes and putting it, like, controlling my environment and then being really careful about the virus. And because I knew it was airborne. And now I'm not an epidemiologist. I'm not a public health official. I know dick about, about viral transmissions, but I remember being, 5 years old, lying on the couch, looking at dust particles in the sunlight. And I'm not stupid enough that when you're in the fall and the leaves are blowing in the wind, that the particles float in the air, right? Or you go out to the ocean and you see the water spray coming off the top of the waves, right? Particles are in the air, and the respiratory virus, is a guest on these host particles. And you don't need a frickin' PhD to tell you that, right? And why it is that people, want to debate it is it's called cognitive dissonance, right? They separate what they're saying from what they actually know. And we know it's in the air because we can see particles in the air. It's all around us. So
we'll get into that in a minute. I know you're with a big group, but I think that's a very good point. And we'll come back to that. But before we do, I want to ask a little bit about HVAC manufacturers and, systems with UV and bipolar ionization and, a lot of different bells and whistles on them. Are we overkilling the design of HVAC? Is there a simpler technology that works well?
Well, both you guys are over 30 now, right? As I am.
Yep.
By a few decades. And you know what? I think you guys would probably agree with me. And, when we're young and stupid, we are like fish. We go after the shiny lures, right? Until we get bitten. And then we start to realize that the stuff that the dead man taught us years ago about keeping it simple works. And it creates a lot less stress and a lot less headaches when you work with the stuff that works. So UV is actually a proven technology. You've had Bill Bonfluff on. I mean, if you want,
absolutely,
sort of the guru of that subject, he could talk for hours and hours on that subject matter. I mean, Shelley Miller and Richard Corsi, all these other guys, the same thing, right? That's a technology that works. Mechanical filtration works, right? MERV 13 plus up to whatever HEPA, whatever you want, like that works for what we're facing, right? A few years ago, I think I'm losing my mind in terms of dates, but I wrote, you were part of it. I think we sent you a copy of the draft version of the indoor air quality awareness course for heating, refrigeration, air conditioning in Canada. Right? Remember that? That was a long time ago.
That was 10, 15 years ago, 10 years right? Anyway.
So I came across a research paper, and I don't remember the university that did it, but they were looking at bipolar ionization and oh man, there was like 4 or 5 I call them zippy technologies, right? And the conclusions in that paper are the same conclusions today. Like nothing, all that's changed is the S&M, which is sales and marketing, or smoke and mirrors.
Yep.
And so and even yesterday, or was it 2 days ago, there was somebody online selling, what do they call it? It was a COVID extinguisher. Right. And they were putting some kind of shit into the air. And it's like, like people and so my message, for those that are listening, to pass the message on, mechanical filtration works. We don't need anything fancier than that. You want to put UV in a room 2K, fine. That's typically upper room type of UV stuff, right? No issue with it, right? The zippy stuff, I don't know. These gray hairs came about from, I'm actually 22 years old. The gray hairs because of the zippy shit.
Well, let me ask you this.
Simple, right?
Well, we had Nate Adams on not long ago. I think you know about Nate, and he's electrify everything. And I think of guys like you when he's on talking about electrifying everything and heat pumps but you're in a somewhat cold region. You have 2 seasons, as Joe would say, this winter and last winter. Will that work in Calgary?
So the technology is getting to a place where we're seeing colder climates being able to use these types of devices. No doubt about it, right? So I remember this is going back probably 15 years ago, 16 years ago. And one of our clients at the time wanted us to use heat pumps. And I told him no. I said, we just don't have enough practical knowledge in our marketplace. And there's like 1.5 million people in the city of Calgary now, but I don't know what it was back then, but probably just under 1 million. And we don't have the support for it. So the technology is there, but there's not enough people around to make sure these things function when they break down, and they will break down. They're a mechanical device, right? So
and it's somewhat complex one too. I mean, they're getting more and more complex as they get more useful in climates like yours.
Right. So, I've always believed, and I was taught this. In fact, Joe probably doesn't remember this because he saw so many young, snotty-nosed, know-it-all kids in colleges and universities when he was doing his rounds for R2000. But I remember sitting in on one of his presentations. This is back in the 80s, like early 80s. And R2000 program which Joe was involved in, had already been launched. It was launched in the 70s. But that philosophy of letting the buildings be the first source of control, right? The building should solve our thermal comfort problems, not furnaces and not boilers and not heat pumps. The mechanical systems are there to compensate for the bad flaws in the building. That's what I was taught. Most indoor environmental issues can be solved with good architecture, good enclosure, good, as I said, the three horsemen. The fourth horseman, the mechanical system, that's just there because the building has flaws, right? So if we're going to use the technology, then we have to make sure that we understand that it will fail, and we have to design for failure in those climate zones like the one I'm in, so that a failure doesn't create a catastrophe, right? You have a failure in a building at -40, and if it's sustained, it changes everything. Pipes freeze, materials freeze, people have to move out, insurance gets involved. They can become disasters, right?
Absolutely.
So you just can't say we're going to throw in technology and that's the solution in extreme climates. It just isn't good engineering practice. So where do you put in the safety factor? You put it into the building, right? So that if the machine breaks down, it doesn't cause a catastrophe, that you can get somebody out to actually get the thing back up and running, right? So heat pumps have been around a long time. They're not new technology by any stretch of the imagination. In fact, I remember talking to somebody from Canada, NRCan, Natural Resource Canada Institute for Research and Construction. This is going back, I think in 1987, someone came by our office and started talking to us about this heat pump stuff. And we didn't, it was not on our radar screen, right? But we paid attention to it. We thought, well, this is interesting stuff. So that's going back into the 80s, right? That I was first exposed to the stuff. And then since that time, it's kept evolving, and the manufacturers are producing, good equipment and for more extreme climates. But I'm going to make a statement here again. This is directly to the manufacturers, because their manufacturers have been notorious of launching products into the marketplace and then withdrawing them because sales couldn't be supported, right? So then you got people out there with all this equipment and there's no support. We see that with solar systems, right? I remember back in the 80s when the governments were, subsidizing solar systems, and everybody and their dog was getting into the business, and then the subsidies went away, and then now there's nobody in business to service the equipment.
Good point. I think you may have answered this to some degree, but what about these electric boilers? I think Bosch has one now, and maybe others. Thoughts?
Yeah. So, I mean, wherever electricity, is the primary source, electric boilers are a nice backup if you want if you're doing a hybrid system, for sure, right? I would be more inclined in some climates to put in a heat pump as I would to put in an electric boiler. But electric boilers, it's not that they don't have a benefit. One of the things that we ought to talk about, and I've done it on a couple of different shows, is talk about this electrification. And in Canada, we have several provinces that are hydropower, right? We have lots of hydropower in British Columbia. We have lots of hydropower in Manitoba. In fact, that's their whole thing. Ontario, Quebec, and these are great places for heat pumps and electric systems. Here in Alberta, our power is generated by coal and gas, and not such a great idea. I mean, and that's a statement that applies to our conversation today in this moment of time, because we can't think that 100 years from now, we're still going to be burning hydrocarbons for, conditioning spaces and people. Right. I remember we were in, I think it was in Halifax or out in the East Coast. I was there for a conference, and there was a guy, I'll never forget it. Actually, he had 3 PhD, oceanography, climatology, and geology. But he grew up the son of a fisherman out on the East Coast. Right. And I think the first thing he said when he got up there, he says, I'm a local boy. I can probably outdrink all of you, but I just happen to have this academic mind. And my mom finally kicked me out of the house a couple of years ago after my 3rd PhD. And so I love the guy right off the bat, right? And he said, one of the things I've learned out of all my studies is temperatures go up and temperatures go down. And he said, but the big thing is that mankind, back then, today we would say people kind or humanity or civilization, is not acting up to its intellectual capacity. Putting a match to create combustion is insane. And the reason for the insanity is that when we turn something into a flame, it reaches temperatures of around 3,000 degrees Fahrenheit or 1,700 degrees Celsius. Well, for crying out loud, we know in these high performance buildings, we can condition the buildings with 77.5 degrees Fahrenheit plus or minus 22.5 degrees Fahrenheit. So basically any temperature on or in the human body is all you need to heat and condition buildings for thermal comfort. So why the F are we creating 3,200 degrees Fahrenheit or 1,700 degrees C? It's absolutely insane. Those are industrial grade temperatures, and we're using them for non-industrial grade applications. And he said that intellectually is absolutely insane. And he's right.
Great story. Great point. I've got a question from, actually, this is from Tom Phillips. For building decarbonization and resilience, what's your take on fabric first, energy efficiency versus heat pumps, PV, et cetera first? I think we kind of talked about that. Europe is taking a former approach.
So I didn't quite understand the question, but I'm going to take a crack at it. So the first solution is the enclosure. Get the loads down. We know that when we can get buildings less than 10 BTUs per hour per square foot of flux, and then using large surface area heat exchangers, the fluid temperatures in those systems on a hydronic system, they're running at like 85, 90 degrees Fahrenheit. That's cooler than blood temperature.
Yeah.
Right. Yeah. And so if to get those things to condense, you need to get the temperatures down, down. And while on those systems, they're returning water temperatures back to the boilers, or if it's a heat pump, down around 75 degrees Fahrenheit. So you're getting these huge COPs and heat pumps, and you're getting huge efficiencies on the boiler side, right? But from an exergy point of view, so exergy talks about the useful work that you get out of a conversion process. And so when we use furnaces or boilers or wood fire for that matter, it's incredibly low exergy efficiency because we could do so much more with those temperatures. So ideally, like 100 years from now, how the industry will be judged it won't be on energy efficiency, it'll be on exergy efficiency. And that is that what work are we getting done, and what's the least amount of entropy, the wasted energy that we're getting from the conversion process and of conditioning buildings. And right now in our lifetime, the ideal environment is get a building down below 10 BTUs per hour per square foot, use large surface area heat exchangers, either radiant systems or large coils in your air handlers, hook it up to a heat pump and run it off of photovoltaics or hydro or something like that with some low entropy system, and you're going to start to get exergy efficiencies up of around the 60%. And that's as good as it's going to get in our lifetime. Unless something else happens, I don't see it ever getting any better than that. So, and the only other way of getting those higher exergy efficiencies is that during the conversion process is to extract heat all the way down to where you're actually dealing with fluid temperatures that are appropriate for the load. So if you're doing, say, for example, a district energy system or a cogen or trigen system, that you're generating steam to drive, say, a turbine for power, and then out of the condensate, you're taking that and you're using a series of cascading heat exchangers, always knocking down the temperature. in the process of doing more work until you get down to less than 100 degrees at somebody's house, and you're using that for conditioning the space. In those cases, you also get high exergy efficiencies. But putting in a furnace and putting in a boiler, and all you're doing is space heating, that's insane. But that's our culture right now. But it won't be our culture forever. And so, you could argue all you like, about combustion efficiencies and buildings, building combinations of buildings with mechanical systems. But ultimately, 100 years from now, we're not going to be burning fuel for heating buildings. It's just stupid.
Great point. All right, let's go to the roundup, John. The roundup is brought to you by April Air, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. April Air, healthy air, healthy home at aprilaire.com. I've got so many more questions. I don't know what we're going to do here, Robert, but I think I want to take the April Air roundup thing. Made me think about something that I didn't even put in, and as a preparation. What about humidity? You're in an area where that humidity gets really, really low. Can you talk a little bit about humidity and its effects on comfort?
So we know humidity has an influence on thermal comfort. It has an influence on people's perception of the air quality in the room. It has an impact on hygroscopic materials. It has an impact on viral transmission, microbials. So you can't ignore it. It has to be, you have to pay attention to it. But you also have to deal with reality. And if you take a look at the inventory of buildings in North America that are in cold climate zones and that they leak, increase in the humidity might be good for people, but it's going to have havoc on the enclosure. And so you can't have control over the humidity if you don't have control over the infiltration, exfiltration in the building. That's the first thing, right? I collect things that have come from places like Boston. I have a duck carving, and I don't know if you guys know anything about Americana history, but back in the Chesapeake Bay area, back in the 1800s, they carved wood decoys, and they had different artists had different skill levels, and you could pay a lot or you could pay a little. Anyways, to put to some perspective, and I'm not in this league, but a pair of mallard, a drake and a hen wood decoy that was carved out in the Chesapeake area a few years ago went for $65,000. We're not talking pennies here, folks. And so, but when you bring artifacts from a climate that humidity is important and you bring them into a dry climate, well, they're going to lose moisture and they're going to start to crack. Well, if you're spending 65 grand on a pair of ducks, and that's not me. I'm not saying that's not me. But if you're bringing in stuff, you don't want it to crack. So you have to maintain humidity. Well, the same thing was with guitars. Like I've got 5 guitars here behind me in my music room. And, you have to maintain a certain level in there. Otherwise the instruments, they lose their tuning and they're affected by dry, they'll start to damage out. So you want to maintain it, but you can't do that unless you control the environment, the enclosure itself, right? So we've seen a lot of good research work, particularly during COVID here, talking about the role that humidity plays in the transmission of the virus, and all of that's good, but it always comes with a caveat. Where can you do that? Like, where can you actually use moisture as a way of controlling it, but in a way that it's not going to cause problems for the building later on? And you guys know, you've been for 15 years, you've been doing the show. How many people have you had on to talk about mold? Like hundreds of people, right?
Right.
So we don't want to create a mold issue and other issues, water damage issues, which you guys again are experts in. But that's the potential when you start to crank up those moistures, above 50-60%, which is, ideally, I always say 35 to 55 plus or minus 5%, because that gives you some wiggle room, right?
You're right. Right.
You have to be able to control it. So,
Cliff?
Okay, yeah. Question from a listener, Scott Armour. Robert, what about retrofits? We see so many buildings with enough failure points it becomes too expensive, but a priority list helps solve some problems. I try to recommend biggest bang for the buck ranking. What are your favorite big bang for the buck retrofits?
seal up the building, get it so that you can actually control the environment. That's the number one. And then would be fixing the enclosure. And I don't mean having to fix the entire enclosure. Like we got asked that question actually from British Columbia, because they've been faced as a lot on the West Coast with rising temperatures. And I don't know if both the United States and Canada this summer lost a lot of people, right? That due to heat exposures. And so, getting the building sealed up so we can control the indoor environment, and then looking at rooms that are critical. So, places where people like to habitate, get those rooms fixed up from the enclosure point of view. Those would be the big bangs for me.
I got another text from Tom. How do you recommend addressing increasing cooling loads and extreme heat in North America, both in the near term and beyond?
It's a great question, Tom. So where my brain went right away was to Winnipeg, Manitoba, because Winnipeg, Manitoba gets as hot as it gets in Florida and as cold as it gets in Fairbanks, Alaska. It's one of the most extreme places on the planet, and it's in Canada. And you have to design first, again, going back to the four horsemen, the first one is the architecture. You got to, for those kinds of extremes, you have to get the architecture right, because you're going to go from hot to cold in 12 months. And it's going to, well, in that case, in Fahrenheit, they would be going from minus 45 to 110. That's a huge delta T. Like, that's just monstrous, right? So any building that's not designed to suppress that kind of change, what happens on the outside is going to happen on the inside, right? That's the fundamental laws of building science. What's out wants in, and what's in wants out. And so control that first with architecture. And then the second thing is then looking at systems, hybrid systems. And when I say a hybrid system for us and in the practice that I had, and it's held true since the very first day I graduated, and that was to use radiant heating and cooling systems as base load systems, control that mass temperature. And then the second thing is then use air-based systems as trim.
Great.
And so we know that in a building, as soon as you can fix the enclosure, the swings in indoor temperature are reduced, drastically reduced. And that comfort zone then is easier to control. And so any flaws in the enclosure that still exist, we can condition with radiant. And it's a radiant problem that we're trying to solve, right? If you could eliminate, people ask me all this all the time, like, what's your favorite mechanical system? Well, I said, well, my favorite mechanical system is one that actually solves the problem. If it's a radiant problem, then don't try to solve it with a furnace or an air-based system. That's just stupid, right? It's a radiant problem, so solve it with a radiant solution. If you can get rid of the radiant solutions, like crazy window to wall ratios and poor performing glass and thermal bridging and all the shit that goes into messing up with the MRT in the space. Well, if you can get rid of all of that, then you don't have a radiant problem anymore. You have a convective problem. So solve it with a convective solution, but don't mix and match, because that just never works.
Great point. Excellent. We didn't even get to touch COVID. You mentioned the word, but
I know I want to touch COVID. I want to do a shout out. Though to my folks.
Please do.
At covidisairborne.com or .org. I got to tell you, thanks for giving me a few seconds here. I don't know how I got into this group. They're the brains in behind COVID is airborne.org are way beyond my intellectual capacity. We have had people in there with Nobel Prize winners, but we are represented by physicians, emergency physicians, general practitioners, epidemiologists, lawyers, accountants, school teachers, every profession. And we're from all over the world. And right at the very beginning, our group said, we're not getting the right information from the World Health Organization. We're not getting our right information from the CDC, both in the United States and Canada. And that's other countries were doing it right, like Thailand, Vietnam, New Zealand, even Australia in the beginning, although they've had some challenges lately. but all of these people that collectively formed this organization have challenged through different means these organizations and the communications. And so what you're seeing, the change in communications about aerosol, as a result of the work that these people that I'm associated with, I shouldn't be associated. They're way smarter than I am, but they're doing great work, and they're passionate, they're smart, their ethos is pure. There's no hidden agenda with these people. All they want to do is they want to save lives. They want to prevent people from getting sick, and they want society to get back up and running, because it's an economic disaster. It's a health disaster. It's a social disaster. And part of it has to do with a field called epidemiology and infectious disease, who have stuck to dogma that was incorrect from the very beginning. And there was a great article that was done in Wired magazine, and then subsequent papers that have been written about it. Bill Bonfleth was part of that. Kim Prather was another one. Lindsay Morris, some really big names that understand this stuff, pointing out the errors. And we're starting finally to get in this people to understand that the errors of their way, but my God, they have created so much problems for us around the world. And people are going to hold them to accountability. And we're starting to see that now, right? We in Alberta here, there was a group, Dr. Vipon and his colleagues started a crowdfunding to put together money to hold our Alberta Health Services to accountability for masking policy with kids in schools. If you have been paying attention, the Prime Minister of Brazil, or the President of Brazil, recent I don't know what it was. There was a board that got together and now recommended that he be charged with crimes against humanity, because the way that he managed the COVID in their country, Brazil, has been a complete disaster, right? And we've seen other political figures now being fired or being held to task for their decision making. And all of that is coming about because of people in this COVID is airborne and affiliated organizations around the world, because we're done. We've fed up with the information. So shout out to my peeps. It's been, having them being able to read the text. It's been awesome. Absolutely awesome to be able. I've learned so much in the last couple of years, but they're good people. And, you need to listen to them.
All right. Before we go, anything you'd like to add, Robert?
Stay safe, you guys. We've got grandkids now, right? We've got 25 more years to enjoy this planet and the friendships that we have. Stay safe.
That's a great way to leave it. Much appreciated. Robert Bean for joining us today. Great guest always, and it's been way too long. We'll have to have you back before 12 years next time.
I'll be in a wheelchair then, but we'll do it for sure.
I may be too, but that's all right. We'll still be doing it. All right. Well, thanks again for joining us. I want to thank my co-host, the Z-Man, Cliff Slotnick. John, you got to have faith at the controls. Most importantly, our growing group of loyal listeners and our sponsors. Can't forget them. Please come back next Friday at noon. By the way, next Friday is a Flashback Friday. 2 weeks from now, we'll be doing a restoration show. We've got Daryl Paulson and Carrie Vermillion on. And then we've got a whole list of shows coming up. They're on the show announcement that goes out on Fridays at noon. Please come back and join us next Friday for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.